Make a table to help draw the polar graph for r equals 4 cos 3 theta. All right, so we're making a table. This is going to be a doozy, or maybe I should say a daisy. Oh, that pun probably won't make sense for about 10 minutes. But if I remember, I'll bring that pun back and remind you why that would be so funny. So I'm going to make a table. In a previous example, what I did is I graphed the polar graph by making the actual graph of the sine or cosine function, whatever it was. Now this is r cos 3 theta. So it's 4 cos 3 theta. So it's gonna peak out at 4. And what's gonna happen, since that's a 3, that means that's gonna be how many times it repeats itself until it hits 2 pi. So I start up here, bottoms out, repeat, bottoms out, repeat, bottoms out, repeat at 2 pi. So as I make this table, I should expect things to repeat. Now, in the previous video, it was, I believe, some number sine theta, and when I graphed that, it was a circle. This is going to take on a different shape because of the number being multiplied to theta. And these shapes will be specific depending on the number multiplied to it. We'll talk about that at the end too. But let's tarry no further. Let's pick all of the angles that I see until I run out of space, because like I said, what's going to happen soon is things are going to start repeating. So I'll pick 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 3, pi, and then we'll see what happens if I need to make any more. All right, I'm going to plug in that theta into 4 cos 3 theta, and that'll give me an r value. All right, so if I do 4 cos 3 times 0, that's going to be 4 cos 0. We'll deal with that when we have to deal with that. 4 cos 3 times theta is going to be 4 cos 3 times pi over 6. 3 pi over 6 is pi over 2. I'll deal with that. 4 cos 3 pi over 3 is pi. 4 cos 3 pi over 2 is 3 pi over 2. 4 cos 3 times 2 pi over 3 is 6 pi over 3, which is 2 pi. Now, wait a minute. 2 pi is the same as 0. Oh, I wonder if this is where things start to repeat. I guess we'll find out. 4 cos 5 times 3 is 15. So 15 pi over 3 is 5 pi over 2. Well, hold on, that's beyond 2 pi. So this is just going to be pi over 2 if I were to subtract. So now we definitely see what's going on. That's the same as pi over 2. This next one is going to be the same as pi, because it would be 3 pi minus pi. So now we're repeating. All right, so let's do the math. Cos 0 is 1. 4 times 1 is 4. Cos pi over 2 is 0. So 4 times 0 is 0. Cos pi is negative 1. 4 times negative 1 is negative 4. Cos 3 pi over 2 is also 0. So 4 times 0 is 0. And now we repeat. So you become 4, you become 0, you become negative 4, and so on and so forth. So let's graph the points that we have right now. Okay, at 0, at angle 0, I go out to 4. At angle pi over 6, I stay at 0. At pi over 3, I go out to negative 4. Oh, I'm going the wrong way. So pi over 3 is going to be over here. 1, 2, 3, 4. Ooh, careful, careful, tricky, tricky. At pi over 2, I'm at 0. At 2 pi over 3, I'm at 1, 2, 3, 4. At 5 pi over 6, I'm at 0. 5 pi over 6. At pi, I'm at 0. At Well, hold on. So basically, if I'm repeating myself, right, this is going to just be like, all right, so what was pi? Pi, again, was -4. So you would be 0, you would be 4, you would be 0, you would be -4, you would be 0, 4. Repeat. So you're 0. You're 4, so I'm repeating my dot. You're 0. You're -4, so backwards 4, repeating my dot. All right, so basically, those are the dots that I have. Those are the dots that I see. A lot of them are just repeating. Okay, no big deal. Now what I need to do is start connecting these things. Okay, I need to start connecting these things. Since what I'm doing is when I'm starting out at 4, as I move towards pi over 6, I'm moving towards 0. So as I move towards pi over 6, I'm heading towards 0, so that happens. As I move towards pi over 3, I'm heading towards -4, so that's going to happen. As I'm moving towards pi over 2, I'm heading to 0, so that's going to happen. As I'm moving towards 2 pi over 3, I'm heading to 4, so that's going to happen. As I move towards 5 pi over 6, I'm heading to 0, so that's going to happen. And as I move towards regular pi, I head to -4, so that's going to happen. And then I repeat, and then I repeat, and then I repeat. Again, I'm at 0, and then this goes to 4. So there's no need for me to draw the same exact outline again because of repetition. So I repeat, okay? Now, what we have here is called a rose, which is what makes the daisy joke so funny. I'll pause for laughter. Okay. Now, fun fact, whenever you have number cos 3 theta, okay, or sine 3 theta for that matter, if you have sine or cosine 3 theta or 5 theta or whatever, if that number is odd, you get a rose with, if it's odd, if n is odd, you get a rose with n petals. So if you see a problem like this on a test and it's for cos 5 theta, you can expect a rose with 5 petals. If it was sine, it would start out at a different spot. It would just kind of shift over a little bit, almost as if this was a fan moving counterclockwise just a little bit. Now, what if this was something like 4 cos even petals? If n is even, what's actually going to happen is you're going to get double the amount of petals and things a lot more symmetrical. So it would be 2n petals. Okay, so if this was 4 cos 4 theta, you can expect a picture where it's 1, 2, 3, 4, 5, 6, 7, 8 total petals. So, yeah. But this is the typical rose problem. We really rose to the occasion on that one. Oh, like and subscribe.